Hello, everybody. Welcome to the API3 workshop. Real-world data for Web3, straight from the source. What does that even mean? It means we run first-party oracles, meaning we aren't the middleman. Okay? So let's get into this. Today, we're going to be doing a workshop about using our AirNode product and APIs, which is price feeds. We're going to do a workshop on paying on-chain royalties with any API of your choosing. Who is this guy standing in front of you and the guy next to you? I am Billy Jitsu. Everybody knows me as Billy. I'm the developer advocate for API3. Ashar, go ahead.
I'm Ashar. I'm a protocol developer for API3.
So double the quality. Okay, so what does API3 provide? Well, we have Chain API, which lets you bring your own API data on-chain. QRNG, that allows us to do random numbers on-chain. And the API price feeds, basically price feeds that are constantly fed on-chain on your local chain. I am in a 20-minute time, so I'm going to go a little bit fast. So today's workshop is going to be used two services that we have, the Chain API plus AirNode and the DAPI price feeds. And so what is an AirNode? In short, they are smart contracts that we have deployed on every chain that you want to use that have the ability to do requests off-chain and then communicate back to your smart contract.
So if I were to just break it down, let's say you have an API and you want to call it on-chain. An AirNode is a very lightweight application that you deploy on a cloud provider like GCP or AWS, which will basically act as an adaptive layer between the API and the blockchain.
So again, how does it work? We have a contract that you have is your requester contract on the very, very left of you. And then we have our AirNode that is deployed that acts as a communication between the off-chain and your smart contract. The AirNode then does requests to our cloud provider and then talks to the API, receives the data, answers back, and then throws it back to your smart contract in a short, easy way manner. And so our other product is DAPIs, which is price feeds. So we have on-chain data feeds that we aggregate data with from multiple sources. And we grab all that data that is provable and bring it into a single price feed for you that is averaged out. You can prove every price feed is coming straight from the source based on their data feed ID, so you can prove that on the smart contract level.
So if, our AirNodes, we took the concept of the AirNode, which anyone can deploy, and we went to very reputable price providers and told them, hey, can you run this AirNode for us? And they run the AirNode. We get the data from them, and then we aggregate it on-chain, basically providing you with data that is straight from the source and that anyone can verify where the data came from, because you can actually see the AirNode is hosted by Nodary or DXFeed or whichever data provider.
Exactly. So what we're going to use today is, again, we're going to mix that Chain API, the off-data information, bringing it on-chain, and the price feeds from DAPI, and we're going to mix the two to make an on-chain royalty payment system. So we're going to go ahead and break down the API. Usually this is a little bit more in detail, but we're going to show you how to use the Chain API with a slideshow because we are unlimited in time. But let's go ahead and break down the API. So for this example, I'm going to be using YouTube. I'm a music producer. I want this YouTuber to get 1 million views. I have an agreement with this person to say, hey, if you get 10,000 views, I will pay you a certain amount of royalties over time. So what we're going to do is we go to the Google Docs, and you can see that we have a getter, which is the Google API's YouTube, which is our main link, and it has videos. If you dig into the docs a little bit more, you look exactly for what you want to see. I highlighted statistics. It's a little bit hard to see here, and it gives me all the information that what I get in statistics. And that's all in the Google Docs. And then that's going to be specific for your API that you want to deploy off-chain. If we looked at that into Postman, it basically breaks down what we want to see, exactly what we want to see here. Can you guys see that okay? I know it's a little bright in here. But it breaks it down into the pieces that we need. We have the base, we have the endpoint, and all the parts that are required for it. So you'll see that we have a part, and then it goes to statistics, and then we have an ID, which is the unique YouTube ID, and then it requires an API key that I need to get permission to read that data. And then you see on the bottom the response that I get. And so what I'm looking for, based on that ID, I want to see the view count. So the view count is what the data that I want to get on-chain. So in our Chain API interface, I'm going to go ahead and do my base URL, which is the Google API's YouTube v3. And then for security measures, I want to put in my API key. So I'm going to go ahead and put that API key as a query. On the next part, it's a simple wizard. as soon as it goes, I'm going to have to do my endpoint. I want videos for my endpoint. And so in my path, again, if you look back, you'll see that I have it on the part with statistics and the ID. So I don't want to hard code it to always get that same video every time. So I'm going to let the user define what they want from that YouTube API. So I'm going to let them, so for the part, I'll say it could be statistics or any other part that they want from the Google Docs. And then the ID, any YouTube ID that they want to choose. So it doesn't have to be my artist, it can be any artist. And then here specifically we have preserve types. Ashar, can you go a little bit deeper in those preserves?
Sure. It's a little bit complicated, but essentially what it is that you want a specific response within the API. You do not want the entire response that the API returns. So you have the user define the path within the API that you want. So in case of the YouTube API, if you'd go like 2 slides back, we want the view count, which is within this JSON response. It's within the items, statistics, view count field. So we have the user define the JSON path, and that's essentially what the path is within Chain API. Okay. And then there's 2 other parameters like type and times. So the type of this response is going to be integer, and the times is if, let's say, we want to multiply it because Ethereum is commonly 18 decimal places, and you have to multiply with 18. But in this case, we don't really want to do that, so we'll just leave it empty.
Yeah, for this example, we're keeping it very simple. If you were doing just a basic integer request online, you can use that as the true number as it is. So for this example, we're keeping it simple. For those that are using OAuth, we have a pre-processing and post-processing. So sometimes you have an API key that only lasts for an hour, and you need to use your authorization to do so. You can do a pre-processing before the request to get an API key as well. But for this one, we're keeping it really, really simple and just having the API key directly in there. So we go ahead and then we create that wizard. It gives us a small file, and we're going to go ahead and deploy that API using either AWS or Google Cloud or any kind of service of your choice. But the wizard helps you with AWS, so we're going to do AWS. And so when I deploy, I just give it any name I want. So I'm just calling it YouTube. And then it's going to be on my version 1 because it's going to be my first deployment. And this wizard takes you to the whole thing. And so I'm choosing AWS. And then it's going to ask me what kind of cloud providers I want. And for this one, I'm using US East. But you have multiple options to choose from. And then it's going to ask you what chains do you want to deploy on. So we have multiple chains that we support, whether on mainnet or testnet. For this one specific one, I'm just using Sepolia, but you can run this on multiple testnets if you want to support multiple chains. For our bounties, we have a sports API that's going to be available across multiple testnets.
Yeah, so this is particularly useful for the bounties that are available in this hackathon because we support all the major L2s as well as some of the major L1s. Mm-hmm. So if you're planning on hacking on the L2s or the L1s, you can mix and match the bounties
yes.
by deploying it here.
And we've kind of already done it for you, so you can almost skip this part. And so authorizers. So depending on how you want to deploy this to production and for testnet, you can have it restricted to only have an allow list of certain contracts or addresses that can do the request. For this example, I'm making it public to anybody, so anybody can make the request. So if you're doing it for testnet or MVP, keep it public. And then it just checks to make sure that we have all our settings are correctly, our versions, where we want to deploy it to, and the networks we want to deploy with. And then we go ahead and gives us a package that we download. And so on the very, very left, you'll see the package contents. It'll have an AWS env, config, JSON, README, and a secrets. In a sense, all you have to do is fill in the AWS, where you have to do your access key ID and your secret access key, which is on your AWS account. And then on the secrets.env file, it's going to ask for a wallet mnemonic. There doesn't need to be any funds. The way this system works is somebody has to pay the gas. When you send a request and get a response, you pay for the request on your first transaction, but then things have to happen a few blocks later. And so somebody has to pay for the gas to get that response. So the sponsor wallet will do that. And this mnemonic generates a sponsor code for then you to fund a little bit later. So it doesn't have to be a funded wallet. It just has to be a random mnemonic. You can make this with a generator or open up MetaMask and just make a brand new wallet and then use those keys. There's no funds required on that. And then depending on the testnets that you supplied, you have to make sure that you have a RPC address. I just went to chainlist.org and then just grabbed a random one. If you have one that you want to be a little bit more solid, you can get one from like Alchemy and Fury or any of these other RPC first providers. And then I'm also inputting my API key for YouTube. This is where you keep it secret to deploy it. So I just have my API key. I already burned it, guys, so don't bother using it. But just for the example, I wanted to show that. That's where you're going to input your API key. So that way it stays on the air node, and then you don't have to give that out publicly. It's not front facing. Okay, and so then once we deploy it, it's going to go ahead to deployment, uses Docker, deploys it, you'll get a success, and then you'll get more files in your folder. And this is the stuff you really, really need in order to use it at the smart contract level. You'll see that you have 2 additional files. You'll have a receipt and log files. And so in the receipt, you're going to get your air node address that's specific to your chain. That's what you're going to use to communicate with our air node smart contract. It's also going to give you an air node extended public address that you'll be used to generate your sponsor wallet. And then in the configuration, you'll also have your endpoint ID. This is the endpoint ID that you'll use to communicate with the API scheme, or sorry, the links scheme. And this is what you're going to need to actually deploy with your smart contract. Anything to add on that?
Yeah, I'll just say that this all seems a little more complicated than it actually is. Once you run through the wizard, the only thing you actually need to do is just deploy the air node, and you're mostly done. And then you have an on-chain address for your API now. Anyone can call that on-chain address and in effect call your API. Yeah. So we are just going through this pretty fast, but I think overall the process is much simpler than it looks.
Yeah. For those hacking with the F1 sports feeds, basically you could skip this entire part because we already did it for you, and you have the air node address and the endpoint ID to work with already. So this would be the only need. We'd need the smart contract addresses. Okay, so I am not a big fan of PowerPoints. I like breaking down code and talking about code. That was the off-chain data stuff. So let's go ahead and build out how we would actually build something here on the space. So let me go ahead and open up my thing. So I know the code looks a little bit scary because it's a lot to swallow. But let me go ahead and Control+ that. But let's go ahead. Sorry. Oh.
More.
Boom.
Cool.
Okay, better? Hopefully? Okay, and let me go ahead and minimize this. Okay, so the proxy address for reading our API price feeds is really, really simple. Literally, you can see like it's 23 lines of code, including my spaces. All it requires is one import for our iproxy.sol library. And I just have one public variable to set our proxy address, which is basically the price feed we're going to choose. Our constructor doesn't require anything. And what we're doing here in this function is literally setting a proxy address. We're telling our smart contract what price feed are we looking to look at. So let's say we want to do ETHUSD or wrap BTC USD. We get to choose whatever proxy address we want to do. And then we literally just read the data feed. And so it's a very, very small lines of code. What we get in return is we get the value, which is the price of the asset at that specific time, and the timestamp of when it was last updated. So we have a certain threshold of 24 hours or a change in deviation of price. If we go over to our marketplace, you can see that we have this one specific one on mainnet. We have a managed DAPI, which is a option of 0.25% deviation, 0.5% deviation, and a 1% deviation, meaning if ETH is $1,000 and it changed price to $990, that would be a 1% change of deviation on chain, and then they would automatically update. And so for smaller deviations and change in price, it would update more frequently or within 24 hours, depending on the range. And you can see that we have current sources. You can actually look at yourself. If you look at the details of what we're getting on chain, we're getting multiple sources from that specific price feed on that specific chain, and we're aggregating all that data down to get you your specific price. And so that is how you would get the market feed on there. And then the second part of this is a request response. Let me zoom in a little bit more here. This one looks a little bit more complicated, but let me break it down very simple. Our request response is basically if you get a request transaction, it's going to call out to the air node, and then it's going to respond. So we have this make request, and we have this fulfillment. What do we do when this number comes back? Our request parameters that we have here is the 3 functions, is basically telling us what chain are you using, so what air node should we port to, what endpoint are you using, so where do we point to, and then who's going to pay for the gas. And that's pretty much our setup. And so the make request is a pretty standard, boilerplate code. You don't really have to change too much around it unless you have something very, very specific out of the box that you're trying to do. And all the magic happens on the fulfillment. So when we get that number in return, or that answer of what we were requesting in return, once we get that answer, what do we do with it? What is the smart contract logic that we're going to do? And I'm literally saying do what you want in this middle of the array here, so then you can go ahead and see that. So let's look at this royalty code, and we'll break it down piece by piece. So this is the music label royalties on-chain system. So let me just break it down really quick. As like we said before, it's in multiple sections. So we're combining the two libraries, request response and the DAPIs. So what I have here is my set proxy address right here hidden. I want to say what asset am I looking to pay with? So I'm going to do ETHUSD. On my set request parameters is basically saying what chain I'm going to do this on, what endpoint I'm going to do this on, which is my Google endpoint API, and then who's going to pay for the gas, which we're going to generate in just a moment. And then we're going to make the request. The only thing that I've changed here is who am I requesting to. So I am doing a request for this one specific artist that I have. So I'm going to register that artist with a specific wallet. So when I do that ID and make sure that they hit enough hits, I'm going to go ahead and make sure that it's that artist. If I have multiple artists, I'll have multiple IDs. So I just have an input to check for that ID. And then the fulfillment array is once we get that view count from YouTube, I'm going to say, well, now that we have the YouTube, what are we going to do with it, right? So the return response is going to give me a number of how many views it hits. And then I'm going to call a function, which is this function right here, which is called payout. I'm going to try to highlight it just a bit. Oh, sure, of course. Better?
A little more.
A little more.
More. Okay.
Perfect. So this payout is just a function that I made to have the logic to be able to check to see if it hits the requirements, if we hit any agreements, if they had 10 views, 100 views, 1,000 views, make sure it's going to check those balances to say, all right, you've hit the requirements, let's go ahead and pay you out. And then now we're going to go into the data feed, right? So we go bring in this DAPI, and you'll see that we have our price feed, right? So we're just basically reading our proxy data, which is going to be ETHUSD. We're going to see the value, we're going to check the timestamp, and we're going to say, okay, this value is legit. Let's go ahead and make sure that this value pays out on that value. And then here is my payout function, which is more logic than anything, is basically saying, okay, has this person hit the milestones? If the milestones have been met, let's go ahead and make sure the views haven't been paid out already. I want to pay you out for 10 views, 100 views, 1,000 views. I want to make sure I'm not paying you twice, so just some checks and balances. Here, I'm actually checking the price of the data feed, so I'm going to check to make sure ETH is this price, so I can make sure that I pay you $100, $1,000 in ETH. ETH changes dynamically, so we want to know at that moment what the price of ETH is. And then I'm doing some conversion. I'm changing it to dollar value. And then I'm making sure that my smart contract has enough funds to pay the royalty out. And then I will then pay that specific artist their bounty. Very, very simple breakdown in here. And so the way we get this all set up is, you know, I have all my variables on here, which should look familiar. We have our air node, sponsor wallet, and endpoint ID that we need to set up parameters, our proxy address, and then I have a global variable for the return response, so you can see simply what the return response that I got. And then I've created another artist ID variable to make sure that I can have multiple artists on here. So if I sign up one artist, their ID 1, 2, 3, 4, to whatever they want. And then I just have a simple mapping to make sure that I have fulfillment requests, because if we do more than one request, we have to keep track of how many requests are being sent and how many requests are being returned to make sure that we're not getting any faulty data. And then I'm also keeping track of how many milestones have been paid per artist on there. And then this is a quick sample of what the milestones are. You know, I'm picking up any random one, so I want to make sure like some YouTube video got 10 views, 100 views, or 1,000 views. It could be 1,000,000 views, whatever is, you know, discussed beforehand. And so I went ahead, you know, the internet is a little funky sometimes at hackathons. It wouldn't be a real hackathon if the internet worked right out of the box. So I went right ahead and deployed it. Okay, and so you can see that when I have the deployment, I have to deploy my air node. So we can go to our providers, and we want to make sure that for this case, I'm doing Sepolia. So I am grabbing, oops, excuse me. Let me go ahead and zoom in. I am grabbing our air node that we have specifically set for our air node at Sepolia Network. And you can see all our test nets have all air nodes deployed on every chain that are available. And so I've already gone ahead and deployed that. And you can see that I have my music label already set. And so I am setting my proxy address because I want to make sure that my smart contract reads the ETHUSD price feed. So I'm going to go ahead to the API3 market. I am going to the Gurley testnet, and I'm sorry, Sepolia testnet.
I think one thing to keep in mind is that the reason we are using the ETHUSD feed in this contract is that we want the user to be able to pay in ETH, and but we charge them a set amount in US dollars. and that's why the data feed is necessary. But you could do this with any of the assets that are listed on the market. So let's say you want the user to pay in a specific currency, maybe not ETH, maybe some other currency. You could also do something of similar. The one thing, like I've seen a similar concept with someone building here in the hackathon, that they are building like a Fiverr on-chain. They wanted to charge people in USD, and what I recommended to them is do something similar as what we are doing here. Is that you just use the data feed to calculate how much ETH you would need to pay for an equivalent amount of USD.
Right. So don't confuse the data feed ID with the proxy address. The data feed ID is up on the top. That is a unique ID for that price feed. The proxy contract address for your smart contract to read is on the very bottom right here, which is the proxy contract address. So you would copy that out and then go in and then set your proxy address. So once we have our parameters, once we have our sponsor wallet, everything set up, now we can request to say, okay, we want to get those IDs. If you follow the repo, we have this encoding structure. You can encode it on the smart contract level if you wanted, but that would require it to be hard-coded. So we have this JavaScript function on the repo where you can then set your parameters and say, all right, I want to get this specific YouTube ID, which is this ID that we have for this one YouTube video, and then I want statistics, and then basically breaking it down on that original JSON response. I want to get the items, statistics, and I want to go specifically to the view count. So you can modify this API to whatever way you want. It's converted into the bytecode, and so you'll see this big, long script of bytecode here. We would grab that information, pop it out into our code, and then we would make our request. And then within our request, we would say, okay, let's go ahead and make our request for here. So we want to see what the statistics counts are for that specific YouTube ID. I've already registered the artist because we have limited time, and that artist is 12. I would make the transaction. It would do the transaction, request, and then based on the sponsor wallet, depending on the time we have, it would then fulfill our request a few blocks later because we have a request received. So we would send out our transaction. It would grab the API a few blocks later, depending on the chain you use on. It would send a fulfillment request, and then we would get it back.
Can we do it in real time, the request?
We can. We got like 1 minute left.
Sure,
Yeah.
sure.
So that's why I pre-deployed it. So if we look right now, I'm going to look at my request. My return response is, I'm going to try to zoom in as much as we can. 792,353, and on that YouTube ID that I used for this one random one right here, it says 792K views, so it averages it down. So you get the exact view count that we get from the API, and then it'll automatically play it in the smart contract level. And then once it goes, it'll distribute all the ETH available to it. So I put this thing with like 0.1 ETH on the smart contract, and it paid it out to the artists that are available and paid out directly. I know that was a lot to swallow. I had 20 minutes to fix that in. So we are in the booth. We can help you deploy your error node. We can help you set up your request response, your DAPIs, and if you're doing random numbers, we can definitely help you get that set up as well. Just to really quick before we go, talk about our bounties. Let me go ahead and slideshow this really, really quick. It's going to take me to the very beginning. There we go. And so we have the best use of DAPI price feeds, which is going to be $4,000. The best use of QRNG, which is our random number generators. We've seen plenty of Uniswap forks. We've seen plenty of lotteries. So spice it up a little bit. You saw the creative usage that I was using for the price feeds to just check the price and make sure we pay out an ETH and dollar value. And then we have 3 API runners up, $1,000 each, to see the best creative idea using any of their technology. If you have any questions, I'll be at the booth all weekend long. It's going to be a grind, guys. Thank you, guys.
Thank you.
Yeah.